Hello AP Statistics students. In this video, we are going to take a look at measures of center. Now, we've mostly done these calculations before, but we're going to take a little bit more of an in-depth look at both the mean and the median. So, our objective here is to calculate measures of center and describe their differences in data that is symmetric, skewed, and has outliers. So, here's our first problem. How long do people spend traveling to work? The answer usually depends on where they live. A random sample was collected from the Census Bureau of traveling times in minutes for workers from North Carolina. Find the mean and the median of this data. Hopefully finding those two numbers is no big deal, but I want to show you a few more things. So the mean, the variable we have for that in shorthand is X bar. Okay, just pronounced X bar because it is an X with a bar on top. Now, the calculation there, of course, we add up all the numbers. And so the way we could write that is we take the first piece of data, X1, plus the second piece of data, X2, plus the third piece of data, X3, and so on and so forth, all the way to the last one. I don't know how many there are, so I'm going to put N. And then you have to divide by how many there are, which is N. Now in math, we're great at condensing things, and so there is a way to condense this down so you don't have to write such a long string. And we use a Greek letter called sigma. This is capital S in Greek, sigma, and in math, that stands for the sum, or add up. We're going to add up all the x's, and then divide by how many there were, which is the letter N. So I want you to be exposed to that Greek letter there, sigma. We don't exactly use it too much, but just know that that sigma means to add up or to sum. That's why we chose the Greek letter S for sum. All right. And I've done that calculation already. You add them all up and you get 540. Divide by how many there are, which was 18, and you get 30. All right, context. What does that mean? It means that on average, the people in North Carolina spend 30 minutes to get to work, or at least in this random sample, they had an average of a 30-minute commute time. All right, now the median. The median is, of course, the middle number, and so you just have to figure out how many there are. There are 18, and so 18 means we're going to have 9 on the left and 9 on the right, and we need to find the one in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9 on the left, 9 on the right. We need the one in the middle. So what is between 20 and 25? If you can't do it in your head, you have to find the average of those two numbers. So add them up and divide by 2. So I've got it right here. 20 plus 25 is 45 divided by 2 is 22.5. When you're doing that on the calculator, make sure you do 20 plus 25 and then hit enter. All right. Order of operations. There's technically parentheses there. So do that first, then divide by 2. And you get 22.5. There's no special letter for the median, mostly because you don't really do calculations with the median, but there are many calculations that use the mean, so that one has a variable. Now, kind of a sidebar here, the difference between a statistic and a parameter. So a statistic is a number that describes a sample. So that's what we just found. These two things, the mean and the median, are statistics in this case because they're describing a random sample that we took. Okay? But you don't always have samples. Sometimes you actually have the entire population's numbers. That's kind of what the census is supposed to be. So if we looked at the entire census, that would be a parameter. So a number that describes a population. So if you have all the numbers. All right, so an example. Let's say you asked 20 random students in the hallway what their GPA was. That would be a sample, that would be a statistic. But let's say you went to a counselor and were able to get the numbers for all of Edison, and you found the GPA, the average GPA of the entire school. Well, that's much more like a population, and so that would be a parameter. The easy way to remember that, statistic has an S in it, sample has an S in it. Parameter starts with a P, population starts with a P. And because those are different, we sometimes use different letters to talk about those. So you can find the average of both of them. You could have a mean of a statistic or a mean of a parameter, but we use different letters for them. So the one we just did, a statistic, is X bar. But if you are doing the mean of a population, you use a Greek letter called mu. It is simply the Greek letter for M, for mean, but pronounced mu. Okay, it's kind of like a U or like an M almost, but with a long tail that goes down to the left. But think of that as an M more than a U shape, but it is the Greek letter M, lowercase, I believe. All right, so between a statistic and a parameter. All right, back to the mean and the median are measures of center. So now I want to be able to talk about what their differences are in data that is symmetric, skewed, and has outliers. So first, the easy one. If our data is pretty much symmetric, okay? If that happens, then your mean and your median are basically the same. All right, I'll write that nice and big over here. If your data is symmetric, then the mean and median are almost the same. Okay. Now, two ways to think of the mean and the median visually. The mean is the balancing point. Okay. If you're looking at a graph, either a histogram or a dot plot or anything, the mean is where you could balance that graph. The median, that has the same number of numbers on the left as the right, that is the point where you have equal areas to the left and right. Now, when your data is symmetric, the balancing point is where there are equal areas to the left and the right. But if you skew the data, then those two are different, okay? So let's take a look at how that works. So I've got an example here. Shopping spree, woot woot. The stem plot displays data on the amount spent by 50 shoppers at a grocery store. Note that the values have been rounded to the nearest dollar. Okay, so we take a look at this. Let's first think about the shape. What overall shape do we have? Okay, I know it's turned vertical, but that is skewed to the right. So where are our mean and median? So the average is at 34.68. So 34.68 is right here. And the median is 28. So where is 28? 20, I believe it's this one right there. So they're no longer in the same place. What happened to the mean versus the median? Well, hopefully you see the median is still kind of right in the peak where it's supposed to be. All right, where it is for a symmetric graph, right at the peak. But the mean has been pulled away. All right, it's farther, in this case, think of it, I know it's down, but think of it to the right. It's been pulled to the right in the direction of the skew. And so our mean changed, but our median didn't really. So here, the mean, or the average, has been pulled to the right. Now, if you want to see that, I did turn the graph sideways over here. So here's the same stem plot, but I flipped it on its side so the right and the left kind of make sense. So here you can see the mean is now to the right of the median. It's been pulled in the direction of the skew. Okay, so pause the video for a second. Can you answer this question? Can you describe where the mean and the median will be in relation to each other in data that is skewed to the left? So pause the video, see if you can write a sentence before me. All right, so hopefully you got that that's been pulled in the direction of the skew. So the mean has been pulled to the left. So the mean is on the left of the median, is what has happened there. All right, one more thing that can affect where the mean and the median are, but it's very similar to the skew. That is if we have outliers. So here's an example where there is a definite outlier in this dot plot way over here. So fuel efficiency. The dot plot shows the difference, highway minus city, in miles per gallon ratings, and miles per gallon for each of 24 model year 2018 cars. Okay, so we got a whole bunch of different types of cars from the year 2018, and the difference versus highway city. Highway miles, they are much better for your car. You always get better gas mileage. Stop and go was actually really bad for your car. All right, so where are the mean and the median? I found those for you already because that's kind of tedious. I don't think you need practice there. The median is at 9. So that's actually 24. Where was it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's somewhere in here is our median. And our mean is 8.4, which is right about here. So that is our mean, X bar, and this is our median. So what happened here? Well, if we were to think about the graph without the outlier, that's pretty symmetric. They should be right on top of each other. But when you add in this outlier, the mean got pulled towards the outlier. All right, that's a heavy point. Think about it like a heavy point. Where do I have to put the balancing point for this seesaw? Well, because I see that way over here, I have to move my balancing point to the left a little bit in order to balance out this seesaw. Okay, so this outlier on the left side pulled the mean to the left. So the very small outlier, aka on the left, pulled the mean to the left of the median. So I'm hoping you can extrapolate that to what would happen if that outlier were on the right side of the data instead of the left. All right, so these ideas, pulling the mean away from the median, is something that we call resistance. Here's a great cheat sheet here of that. I found that picture on the internet. If you want to do a quick draw there, you can pause the video, but that is a good summary of how the mean and the median are related to each other in different skewed graphs, and it also goes with outliers. So this brings us to the idea of resistance, okay? The mean is not a resistant measure of center because outliers and skewed shapes have a big effect. The median is a resistant measure of center because outliers and skewed shapes have less effect. They do move it a little bit because you're adding values if there's outliers, but very little effect at all on the median. So that is the idea of resistance. The mean is not a resistant measure, while the median is a resistant measure. All right, I hope that makes some sense. If not, ask me some questions. Good luck.